Hello. Finally, we have solved the angular part of the wave function. Now, the last part in solving the hydrogen atom is the solution to the radial part. Okay, so if you haven't watched the solution to the angular part, I recommend that you go back to this first. So let's now try to find the solution for the radial part. So recall that we have a radial equation . This is written as r dr. Sorry, this should be squared plus 2mr squared over h bar squared times the total energy plus the potential for pi epsilon naught 1 over r times r minus ar equals 0. Now from our angular part solution, since we have introduced Legendre polynomials, we have limited a to have values between a to have values in L to be L times L plus 1. So for the sake of simplicity, we will be only interested in the ground state for our radial equation. The other states, n equals 2, 3, 4, and so on, are quite tedious to work on, and it is solved in a formal quantum mechanics class. But since this is just a general physics class, we will limit our solution to the ground state, wherein n equals 1 and L equals 0, m equals 0. Just to give you a feel of the solution in the radial equation. So setting L equals 0 and m equals 0, this term will get a equals 0, so this will be now 0. Okay, so now we focus on this term. So this will be solved by a product rule. So we have here r square, second derivative of r with respect to dr plus 2r dr, capital R, dr. Then here we have plus 2mr square over h bar square times e plus 1 over r for pi epsilon naught equals 0. So notice that this is a differential equation wherein we have a second derivative, a first derivative in r, and a constant in r. I forgot to write this constant. Constant in r. So for the next video, we will be solving this differential equation.